All right, we're on the home stretch. Our Space Invaders clone and Zig and Raylib is coming together quite nicely. But what we need to do is make it so when I get hit, if I get hit, I'm too good at this game. Uh, when we get this game over screen and we press enter to play again, it actually resets the game instead of takes us back to where we were. That's weird. So let's do that. So we're going to do that. We're going to set up a victory screen, and I think we will send the player off with a working Space Invaders game to play around with and have fun with. So let's check when they win. Okay, we have a game over Boolean up here at the top. So what we're going to do is add another Boolean called game one. This is also going to be false. And we have an unused local variable, but that's okay. We are going to use it. So what we're going to do is come back down to our game loop. We're going to find our invader movement code. And then we're going to add a check. So right before we draw everything, let's check the state and figure out if everything is good to go. And we can say var all invaders dead is true. It'll be true until we've been proven otherwise. So we have our invaders. It's going to give me a pointer to a row. Keep in mind, this is a 2D array. And then we want to take our row, and that's going to give me a pointer to an invader. And what I want to do is check if invader.alive, and if it's true, then all invaders dead is false. And then break. And then down here, if all invaders are dead, then we can break out of our loop. So down here, we can check if all invaders are dead, then the game one is true. And now the players won the game. So we loop through any of the invaders, we find if any are alive, and then we set the flag to false and break. If we finish without finding any, the player wins. Now, one thing that's kind of interesting that we've actually seen a couple good scenarios for, but I haven't introduced yet, are the concepts known as labeled blocks. So this is interesting, right? What we're essentially doing here is we're using this flag and we're breaking. And then we're checking this flag and then we're breaking. But there's actually a simpler way to do this with one fewer break. So what we can do is use a label in Zig. So I can create a label called like outer loop. But what I can do is come down here and say break outer loop. And now I don't need this. So we could take this approach too. I think this is a good approach. So yeah, let's do this instead. We're going to head back up to the start of our game loop, and we're going to essentially do the same thing we did with our game over. So much, in fact, that I am just going to copy it and paste it, and then change this from game over to game one. And then I'll change this to you win. I'll update these positions to be a little closer to the center. So like 320, and then this should not be red. It seems bad, so let's do gold. We have our score text. We still want to show the final score. I think this is fine. Our position may change here because the text that we're drawing above it is a little smaller. So we can do 280, 310. That seems good. We'll keep the same thing that says press enter to play again or escape to quit. Seems good. And then this is important. We need to change this from game over to game one. Now, an interesting little tidbit that you could do here is actually, instead of modeling it like this with these Booleans, you can't be in a state where the game is over and the game is won based off the logic that we've provided. So maybe a better example would be an enum or a state machine. And that's something that I think would be a fun little exercise to refactor towards. I would encourage you to try that on your own by reading the Zig documentation and figuring out how enums work. But also, there's a chance that I may do that at the end of this video anyways. I already feel like there's quite a few things that I could refactor to help prove out some more core concepts with Zig, and we'll see. I may do a video on that as well. So we already have some lose conditions, which is the player is hit by a bullet. But we technically need to add another. If the invaders reach a player, the player loses. So in our invader collision checking code, which is somewhere down here, so I will add 4 And we're going to iterate through the invaders again. Row for row. And that's going to give me a pointer to an invader. If the invader is alive, then we'll do some rect bound checking. So we'll do if invader.getRect.intersects with player.getRect, then game over is true. So the last thing we need to do is implement a reset game function. So when the player presses enter on the game over or the game one screen, we need to reset everything. So we're going to create a function for this because there's actually quite a bit that's going on here. So we're going to hop back up to the top of our main method, which is right here. And what I want to do is create another function called reset game. And reset game is going to take in a lot. So it's going to take in the player, so it can reposition them. It's going to take in the bullets. It's going to take in the enemy bullets. It's going to take in the shields. It's going to take in the invaders. And I'm actually going to use something kind of interesting here. There is this type in Zig referred to as an any type. And essentially what any type is telling the compiler, this can be any type as long as it implements the things I need it to in the method or the function I am using them in. So that's a little weird, but you can think of it as kind of like a bit of inferred typing. And you'll see how that works here in just a minute. There is a trade-off, unfortunately. I find that the language server doesn't do as great of a job suggesting things when you have an any type, but let's walk through it and you can see how it's used. We need the invader direction. We need to reset that. And notice we're taking a pointer to the float. And then the score needs to be reset. So we're taking in a pointer to an I32. And we're taking in the config, which is going to be our game config, which we built a long time ago and have not used. So this will give us an opportunity to use that as well. So the first thing I want to do is set the score equal to 0, and then I want to set the player equal to player.init. I think we can just copy the value right down here. So let's just grab all of this. I think that should be good. Oh, we are missing our return type up here. Sorry, let's add that. So we're just returning void. We need the screen width, which actually is coming in from the config, the player width, which is also coming in from the config, and the screen height, which is also coming in from the config. All of these actually come in from the config. So maybe I shouldn't have copied that. Maybe I should have just typed it out. Would have been a little more clear. Okay, so we're setting up our player. We need to set up our bullets, or more importantly, we just need to deactivate all of our bullets. So we can do bullet.active is false. We need to do the same thing for enemy bullets. Bullet.active is false. We need to iterate through our shields, rebuild those with all of the positioning and everything too. So it's a little bit more involved, but we can do for shields ... This gives us a pointer to a shield and an index. Const x is config.shield start as F32 float from int I times config.shield spacing. And then we need to set the actual shield itself like so. So shield.init x config shield y. And we need a width, which is config shield width, and then config.shield height. Nice. Okay, outside of our shields, we need to reset our invaders. So that's going to be 4 invaders, 0 dot dot. And then we have, again, a row, and we get an index. So what I need to do now is get the row and another index. Or sorry, I need to get the invader and another index. Invader, J, seems good. And then we can do something like const x is config.invader start x plus as f32 float from int j times config.invader spacing x. Const y is going to be config.invader start y plus as f32 float from int. And interestingly enough, I mentioned any type, but you can see that the type for float from int is also an any type. And we have our config, multiplied by our config invader spacing y. Finally, we can actually initialize that invader again, invader.init x y config.invader width config.invader height. Invader direction goes back to neutral, so 1, a positive value in our case. And this resets everything to the initial state. Notice that we use pointers for the things that we're modifying. Now we can create our game config in our instance, create our game config instance in main. So if we come down here, maybe somewhere like this, what we can do is set up our const config, which is a game config. We have a lot to add, so let's add these things. So we have our screen width, which is screen width, our screen height, which is our screen height, our player width, player width, player height, player height, bullet width, bullet width, bullet height, shield start X, and then our shield start Y. Oh, sorry, just shield Y. Shield Y, our shield width, shield height, shield spacing, invader start X, which is invader start X. You get the idea. I'm going to type these out and we'll continue to say them because we're almost finished. But yeah, you get the idea. We're essentially creating this giant config struct, invader start X, start Y, and we are using this to reset things from the game. Invader width and invader height. Finally, invader spacing X. And then invader spacing Y. And that should be our config object. Oh, except player width is not declared. Yeah, okay, player width and player height's not declared because they're declared further below. So I'm just going to grab those and bring them up here, and then we will paste them where they belong with the other consts. Okay, so we have our config, which is great. We have that, so we can pass it around. And what we can do is essentially call reset in both of these screens. So we said that we'll do the reset later. Now is later. So we're passing in a reference to our player. We're passing in a reference to our bullets. We're passing in a reference to enemy bullets, passing in a reference to shields, passing in a reference to invaders, passing in a reference to invader direction, reference to our score, and then finally our config. I'm going to add a comma here so Zig formats this a little nicer for me. And then what I want to do is I'm just going to yank 10 lines. And then we'll come down here and we'll do the exact same thing with our reset game. So now we're calling reset game in both those screens. So now the game is fully playable with restart. I say that. Let me Zig build run and make sure I didn't mess anything up. Does not look promising. We're missing a struct field. Player start Y on 349. Was that declared somewhere? Did I miss that? Yeah, I guess it wasn't declared anywhere. Let me just come up here and add this. So that gives us our player start Y. Change this here to be our player start Y. $297 we cannot assign to a constant. So let's figure that out. Oh yeah, so these enemy bullets should actually be a pointer to an enemy bullet, not a non-pointer. Okay, cool. So we have something going. I'm just gonna shoot a bunch and get hit. And now when I press enter to play again, everything restarts. Perfect. Our score is set to 0. Our shields are back to full. Our player's back in the center. Our invaders are moving like crazy. They're firing bullets. Everything's good. So we have built, over the course of however long it's taken to get through these videos on your end, I would assume maybe a couple hours, we've built a Space Invaders clone in Zig that runs on Linux, it runs on Mac, it runs on Windows. It actually doesn't highlight all of the intricacies of Zig, which is what I originally set out to do. But if you are familiar with Zig, you might have noticed we've not really used an allocator, for example. We've not done anything with I/O. We've not done any reading files or anything that's interesting. So maybe I will do another course at some point that expands upon this project and adds things like saving the leaderboards to a file. Yeah, I don't know. There's some flexibility that we could do there where reading and writing to the file could give us an opportunity to mess with the file system and maybe allocators and some other fun stuff. But for now, I think we have a really awesome project that shows off some of the cool parts about Zig. Hopefully you do too. And if you found this course helpful, I would love it if you would let me know. Your feedback helps me figure out where I should spend my time because I want to spend my time learning and growing, but also helping others learn and grow. So please, if you haven't yet, let me know in the comments on either a video or hop in the Code with Cypher Discord and let me know your thoughts in any of either the general channel or the course-specific channel. It would mean a lot to me. I think that's it. So thank you very much for sticking with me through this entire course. I really appreciate it. Hopefully you learned a lot and have a fantastic day. Thank you.